Hi learners, I am Dr. Prabhat Dwivedi, Associate Professor STEP-HBTI. Today I am here with the presentation on determining the size of the sample. As we know that a researcher has to take a number of sampling decisions, and the quality and outcome of research largely depends on how correct decisions have been made about the sample and its size. So today's lecture is going to be fruitful for all of us. Now, what are various factors which influences size of the sample? There are a number of factors such as the nature of study, whether the study is qualitative or quantitative. Another is purpose of the study, and next is size of the target population, and the next is risk of selection of bad sample. And lastly, the permissible sampling error. Let's take one by one these factors in the discussion. First one is nature of the study. For example, when the study is qualitative in nature, what would be the determinants which would decide size of the sample? Generally speaking, in qualitative studies, size of the sample is small. And how much it is small? The question is often asked by the students and researchers. So the general answer is until the point of theoretical saturation is reached. That's the ultimate answer for this. Theoretical saturation. And that every researcher has to know what is theoretical saturation point in his or her study. Theoretical saturation means, how many respondents have provided how much content about a particular variable or factor, by which a researcher can justify that this much is sufficient, this much is enough to justify this or to make this statement. Next is the sample must be representative. This point is valid not only for this qualitative study but also for the quantitative ones as well. Sample should always be representative of the target population of the sampling frame. And the next one is the qualitative studies. Finding size of the sample is flexible and it is often a pragmatic approach. Flexible in the sense that nothing hard and fast to decide about how much size of the sample should be representative and should be called the right one. You may say 30 respondents are enough for this study. I may say 25 respondents are enough for this study. And both may be true. Both may be justifiable. Pragmatic approach is one which is, practical. I mean, we need to have the sample size which is practically feasible and possible. And the last point related to it, which also influences the size of the sample, is judgment. Judgment of whose? Judgment of the researcher. Researcher has to understand who is the right respondent and how much knowledgeable he is, how much right person he is for the sample to be selected. And expertise of researcher as well as that of respondent. Researcher has to include those people in the sample who have the relevant experience, who have something to say about the variable, about the factor, and who can provide the better quality of information so that he can be satisfied or she can be satisfied about the quality of information has been received from that respondent. Now, the next factor is respondents' relevance. If respondents are relevant about the study, we can say the person should be selected in the study. Otherwise, he or she should not be selected in the study. Now, the key suggestions are: select most productive sample. It means we should be so much careful about selection of the respondents in our sample. Because if sample is not productive, if respondents are not answering the questions, if they are not eligible to answer the question, the sample unit may be unproductive and the exercise would be futile. So if we are going to select 30 people, 20 people, 30 respondents, 20 respondents, we have to think of that most of them or almost all of them should be productive. But nobody can be 100% sure of it. But we should try it. And the next suggestion is develop a framework of variable that may influence an individual's contribution. As before, designing the research protocol, data collection protocol, we have to find out the variables and we have to build up a framework of variable which may influence an individual's contribution. On that basis of the framework of variable, we select respondents in our sample. So we have, prior to going for the interview, in-depth interview, we have to build up a framework of variable. Next suggestion is, if the researcher knows the subjects, they may be stratified according to known public attributes or beliefs. As we all know that stratification is required while the sampling, just because of making or getting those subgroups of population which are more homogeneous internally. There is not much more variation in the group. Just to reduce variation, just to get the uniformity amongst the data, amongst the sampling units, we go for stratification. And before doing stratification, we have to have the sufficient knowledge about the subject. Subject means often respondents. We have to have adequate knowledge about the respondents. Next suggestion is that if broad range of subjects are available, we need not to neglect them. We need not to ignore them. In broad range of subjects, there must be outliers. No doubt, there must be outliers. But we need to recognize them. Which are outliers? Subjects who have a specific experience. These are known as critical case sampling. Sometimes we have to focus more on the subjects who have a specific type of experience which is more suitable for our studies. We have not to leave them. We have to cover outliers. We have to cover those subjects who have a specific experience. We have to cover those subjects who have a special expertise, like key informant samples. Those are key informant. If we are talking about a study related to corona and its impact on the humanity and impact on the economy, we have to have experts related to academia, experts related to economy, experts related to health and medical sciences. They may be called key informant, and the sample may be called key informant sample. And lastly, amongst the suggestions is maximum variation sample. As I told you already, that we need not to ignore those who have variations, with those data points who have variations amongst all. we have to cover them. Now, continuing to the next slide, key suggestions may also include, like, these are crystally cleared key suggestions, brief key suggestions, such as, if we are going to be concrete enough, we can say the smallest sample size may be 15 in case of the qualitative studies, and the maximum number of participants or the maximum size of the sample may be 50, should not exceed 50. That means the sample size for qualitative study may be between 15 and 50, not less than 15, but not more than 50. Another key suggestion is the optimum number of participants in a focus group should not be exceed to 8 and should not be less than 6. For an FGD, the optimum size of the sample should be between 6 and 8, and should be at least 2 FGDs per population group. If there are subgroups, if there are strata, then at least 2 FGDs should belong to per strata. Or if there is no strata, at least 2 FGDs should be for that population group. And again, I am reiterating the point that theoretical saturation should be attained. Researcher should ensure that that much FGDs should be conducted which can draw the theoretical saturation. That much in-depth interviews should be conducted which could draw the theoretical saturation. And lastly, to summarize this point, I could say that this choice of numbers should be justifiable. It should always be justifiable. Now here we can have a glance on this diagram, which is diagram related to the quantitative study. When the study is quantitative, how can we determine size of the sample? There are 3 main determinants of the size. One is level of precision. Level of precision depends on the 2 factors. One, range in which the true value of the population is estimated to be. And another, this range is often expressed in percentage points, like how much precision I want, how much accuracy I want. That is the precision, 95% accuracy. Then how much permissible error is? 5%. 90% of precision means how much permissible error is? 10%. So this is the one factor which determines the sample size in case of qualitative studies, that is level of precision. Another is level of confidence or risk. With how much confidence one can say the result will lie in which range. That is known as confidence interval. For sample statistic to be lying in the parameters between in the range of parameters. For example, range of parameter is 90 to 95%. Then how much probability of the statistics to lie between this range? That is level of confidence or level of risk. When we say 95% confidence level, that means 5% I am not sure that this statistic will fall in the confidence interval. But 95% I am sure that this will fall in the confidence interval. This is what the level of confidence or the risk. Opposite of the level of confidence is the risk. If I am saying that 95% is the level of confidence, that means 5% is the risk. And the third factor is the degree of variability in the attributes being measured. This depends on three factors. It actually refers to the distribution. Degree of variability refers to the distribution of attributes in the population. How much I am picking up the correct population. That is, how much my variables or attributes are uniformly distributed on the population. Next is related to this, the more heterogeneous a population is, the larger the sample size required. As I have told you earlier as well, when population is very homogeneous, we can take a small sample and results getting from this sample can be generalized onto the entire population. But when the population is quite heterogeneous in nature, then I need to take larger sample size to reduce the degree of variability. And the last point related to this is, the more homogeneous a population is, the smaller sample size is required. This is what I have already told you. The same thing is repeating here. So, what are other factors which are determining sample size? Is concrete points I am telling you. Suggested sample size for a quantitative study may be like minimum is 30 and maximum is 1000. One more important factor is that a 50% proportion of the population indicates a greater level of variability. In a diagram present in the next slide will show you this point, will make you clear this point, how 50% proportion of population may indicate greater level of variability. That is, you have covered almost 100% level of variability and you need not to worry about that your sample size is small if you have covered 50% proportion of the population in your sample. And sample size, as I have already told you, that sample size influences accuracy of representation. The larger is the sample size, the better accuracy you can achieve. The next diagram we can see in the next slide, but before that we can have an eye on this slide, which is showing you strategies for determining sample size. How can we go for the census studies? Of course, I have told you earlier that if this population size is small, for example less than 200, we can go for the census study. Another point related to this, another strategy related to determining sample size in quantitative studies is that we can imitate sample size of similar studies. This is in fact a wonderful idea. Similar studies would have been conducted already. So we can go through the justification they have given for their sample size. We can go through the justification for sampling techniques they have already given in their studies. So this is wonderful idea to imitate sample size of the similar studies. But a careful review of those papers is required. Sometimes paper may not be up to the mark. Paper may have not been published in a good journal. So it may have published in very substandard journal, so the content, the justifications, the quality of the paper would have been quite substandard. And if we imitate those studies, we of course would land in trouble, and our paper or our study would not achieve that recognition which it would have been deserving to achieve. Next strategy is use published tables. This is again a wonderful idea. There are published tables which shows the parameters, the factors, and the population size. Based on those factors and population size, we can of course select an optimal sample size, because those published tables are hinting us to do so, and they are scientifically built up. So we will not land in trouble if we go through those published tables, and based on those tables we get an idea about our sample size for our study. So that is very good, which is based on the precision and confidence level. They have already determined the sample size. So this is wonderful to refer to those published tables. And the last strategy we can read in this slide is apply formula for calculating sample size. When all these previous things don't work, we have then formula to apply. These are the published tables. You can go through here. Percentage of population proportion is given, which I was talking about in earlier slides, and population size is given here. How much percentage proportion, or how much error we can permit. If we can permit 5% error, that means we want to achieve 95% interval. If we want to permit 7% error, that means we want to achieve 93% accuracy, precision. If we want to permit, we can permit 10% error, that means we can go for the precision level of 10%. So sample size with plus minus 5% precision level, 7% precision level, 10% precision level, with the interval, with the confidence level, that is 0.5, that means with the confidence interval 95%, confidence level 95%. These are the fixed parameters. On that basis table has been made. So this table which is published here, this is for the confidence level, that is 95%, and P precision level are 5% level, 5%, 7%, 10%, and error probability is 5%. Population proportion is 50%. As I told you, in 50% population proportion, we can achieve up to the 100%. Close to 100% variability of the data. So that is what the proportion, that is 0.5, which is showing here is 50%. So here for an example, we can see that if plus minus 50% error I can allow with the population size 100% and 95% confidence level, then 81 should be the sample size. If there are 450 population size with the 50% proportion, and with 5% error, permissible error, 212 should be the population size. Sample size. So this is how the published tables are there, which we can always refer to. There are so many published tables are available. We can find them out. Now last strategy of devising or determining the sample size is the formula. So formula here is known as quotient equation. This quotient equation is before you. This is like n equal to z alpha square dot p dot q upon e square. What this formula denotes? What terms of this formula denotes? we can just enlarge this slide and go through it. Taking the slide back. Yeah. Now, see, a small n denotes sample size. This denotes sample size. And just hold on. Z alpha denotes the Z value of alpha error. Alpha is permissible error, and this like value of Z at 5%, value of Z at 7%, value of Z at 10%, value of Z at 1%, value of Z at 0.5%, we can calculate from the Z table. 1 point alpha is confidence level. When I would reduce the probability of error from 1, I'll always get confidence level. This can be denoted in point, in decimal, as well as in percentage. I can say 0.5, and at the same time 0.5 level of error and 95% of confidence level. Similarly, I can say 1 minus alpha, that I can denote with 95% confidence level. So this is what the precision, desired precision I want. If I want that my sample should be 95% precise, that means Z alpha is 5%. P is estimate of the proportion. That is what I said. 50% estimate proportion of the population. As I told you, if we can achieve 50% population proportion, that means we are going to get almost 99% attributes of the population, entire population. That is what the value of P. So P means 0.5, 50% means 0.5, and Q denotes here 1 minus P. That means 1 minus P will again be 0.5. So now I can apply the formula, that is what small n equal to Z square into P into Q upon E square. E is what? E is the desired level of precision, how much precision I want. That is the value of E. 0.5%, 5%, 7%, 10%, that is plus minus, we can calculate that. That is given, not we can calculate. That will be given if we are solving a numerical. Otherwise, as a researcher, we have to decide what precision I should get, what a desired level of precision for my research. This is what the formula. When the population size is finite, like we know how much is the population, then value of n will be given to us, or I would be knowing the value of n, capital N in fact. Then the size of the sample would be n0, that is sample size calculated through the Cochran value, n0 upon 1 plus n0 minus 1 upon capital N, that is population size. Another formula is also given by, this is a simple formula in fact, that is known as Emmons Formula. This is devised by Emmons in 1967. This is based on certain assumptions like confidence level is 95%, proportion of the population is 50%, where small n denotes sample size, capital N denotes population size, and E is again the level of precision. So the above formula can be simplified at the formula given below of the above formula, that is a small n equal to capital N upon 1 plus capital N into E square. This is very simple formula on the assumption that confidence level is 95%, P is 0.5. Based on that, the above formula can be resolved. By putting those values, the above formula can be resolved into the formula given below, and that becomes quite simple. Here, if I have the value of population and the value of precision level, I can very easily and simply determine the value of sample. That means the size of the sample. This is how I can calculate the formula. I can calculate size of the sample. But lastly, I would say there is a warning while taking decision about the sample. There is always risk for sample may be too small or sample may be too large. But in fact, a large sample is never bad. But a small sample is really bad. A small sample can, make our entire, research exercise futile. So beware and question yourself that the sample size determined by me is good or bad. It should always be good, because too small sample may produce inconclusive results and could also be considered unethical. But in fact, at the same time, there is no sample size which we can call too large sample. In fact, if we can say that if any drawback can be of a large sample, that can be that this may waste our scarce resources and could expose more participants than necessary to any related risk and nothing else. But small sample size produces a number of issues. So, dear students, that's all for today's session. Thank you so much.